Hi, Mr. Ford here. And today what we're going to be doing is we're going to be learning how to multiply double-digit numbers using the traditional multiplication method and the lattice multiplication method. In both cases, the principle of what you're doing is the same. You're taking larger factors like 12 and 23, and you're breaking them down into single digits to multiply. The purpose of this method is that at this point, if you've created automatic recall or close to automatic recall of most of the single digit factors, 0 to 9, breaking down these larger numbers into those single digits makes it very easy to multiply, regardless of how large the number is. So with traditional multiplication, we stack our problem vertically, one factor on top of the other, and we set it up very similar to traditional addition or subtraction. We've got our operation symbol on the left-hand side here. We've got our multiplication symbol. We've got our vinculum or our equals bar on the bottom, so we know that our product, our answer, is going down here. But there's a couple key differences, and we'll talk about those as we solve the problem. So with our first problem here, 12 multiplied by 23, just like in addition and subtraction, we start in the smallest place value, in this case, the ones. There are no decimal numbers here, so the ones is our smallest place value. And we have 2 multiplied by 3. And we know that 2 multiplied by 3 is 6. So what we're going to do is we're going to just go ahead and write a 6 down here. Everything seems to be making sense. It's quite similar to how we add and subtract, but the next step is different. And it's very important not to skip this, or else you'll end up with products that are just completely incorrect. In traditional multiplication, you are splitting larger factors into their different place values. So instead of multiplying 3 multiplied by 12 or 23 multiplied by 12, you're going to multiply 3 by 2, which we just did. And then you're going to go diagonally. And you're going to multiply 3 by 1, which is 3. You're going to write that down here. So now we have 36, but we still haven't used this 2 over here, this 20 from 23. So instead of multiplying things by 20, which would cause us to have quite a mess down here, because our bottom factor, 23, has 2 place values, we're going to put a placeholder, a 0, underneath this 6. Now, some people do this as a 0. That's what it represents. Some people just leave a space. Some people put an X or some other symbol. The important thing to note is that when you're doing this, for the tens place value, you need to add a 0 underneath the first section of product you have calculated. Because essentially at this point, what we've done is we've multiplied 12 by 3 to get 36. 3 12s is 36. But now we need to multiply 20. But again, the whole purpose of traditional multiplication is that we don't have to multiply these large factors. We can break them down. So we put that 0 there. So instead of thinking about this 2 as a 20, we can just relax our brains and think of it like a 2. Just like we did with our 3, we need to start, I'll switch colors here, we need to start by multiplying the smallest factor. So 2, in this case, is going to multiply with 2 to get 4. And then it only has one part of 12 left to multiply by, and that is 1. 2 multiplied by 1 is 2. And what we have here now are 2 products two halves of our problem that we need to add together. So we have 3 multiplied by 12, that's 36. We have 20, because remember this 2 is in the tens spot, so it's 20, multiplied by 12, which gets us 240. We just go ahead and add these together. And we get a product of 276. So we're going to try this method one more time and this problem over here. What we're going to do is we're going to have some factors where the product is going to be larger than 10. So we're going to need to do some regrouping. I'll talk about what that looks like in traditional multiplication. So in this second problem, 32 multiplied by 16, just as we did with our first problem. Actually, you know what? I will switch colors. We'll keep it consistent. We have 6 multiplied by 2, which is 12. Just like in addition and subtraction, we're going to go ahead and we're going to put the 2 from 12 down here, and we're going to regroup the 1 over here. Next, we need to multiply diagonally. 6 multiplied by 3. We are not adding that regrouped number to the 3 and multiplying 6 by 4 because we're not doing 42 multiplied by 6. We're doing 32 multiplied by 6. And so this is important. Sometimes people get confused because they're so used to adding the regrouped number and then adding their two addends together. We don't do that in multiplication. The adding happens second. So 3 multiplied by 6 is 18. Add 1 is 19. Now that we've multiplied our factor 6 by 32 to get 192, we're going to put our 0, our placeholder, because this 1 is actually a 10. We just don't want to think of it like a 10. And we're going to go ahead and multiply 1 by our different components. So 1 multiplied by 2 is 2. Remember, this regrouped 1 is gone. We've used it. If you need to, you can cross it out. You don't want to accidentally use the same regrouped number twice. 1 multiplied by 3 is 3. And just like we did with our first problem, we're going to go ahead and add these together. 9 and 2 is 11, so we regroup there. And we end up with a product of 512. So this is the traditional multiplication method. And this is the one that if you are educated in Canada or the United States or the United Kingdom, you're probably going to see this one the most. All right, a number of the Commonwealth countries as well, you'll probably see this one the most. And all we've done is we've broken our larger factors into smaller pieces, and this can be done for any size number. So we've only really had to challenge our brains to multiply single-digit factors, even though the numbers that we're working with are substantially larger than single digits. So let's head over to lattice multiplication, and let's see what that looks like. So here we have the same two problems. 12 multiplied by 23 and 32 multiplied by 16. We already know the products. All right, if we come back here, the first product is 276 and the second product is 512. So we're going to go ahead and just write those at the bottom. 276 and 500. Ooh, that's a wild 5. 12. And we're going to see how we can come up with the same products using lattice multiplication. So lattice multiplication, there's a little bit more to the setup. Your vinculum and your operation symbol instead go away, and it's replaced with this grid, this lattice, if you will. And your top factor, your first factor, goes on top. Your second factor goes on the side. The number of boxes you have, the size of your grid, is going to be equal to the number of digits you have in terms of columns and rows. So if you have 2 digits on top, you have 2 columns. If you have 2 digits on the side, you have 2 rows. If this were, let's say 812, we would have a whole other column with 2 rows to organize ourselves. And so the setup for lattice multiplication is quite important. If you don't set up your grid properly, that seems to be the most common way that you end up with an error. So once you've set up your grid, what you're going to do is you're going to find the furthest corner on the right-hand side, and you're going to draw a line diagonally out of your grid. And you're going to repeat this for all other corners. The lines go in the same direction. They're all going to the bottom left. I would suggest, if you're going to use this method, that you do this with a ruler or a straight edge of some sort. So now we've essentially turned our grid into a series of triangles, and we have these open-ended spaces coming off of our grid at the end. These open-ended spaces are where our product is going to go. All of our calculating, all of our computation is going to happen inside the triangles. So what we do now in lattice multiplication is we pick the 2 closest factors, or the 2 closest digits from our 2 factors, and we multiply them together. So 2 multiplied by 2 is 4. This 2 lines up with this section of the grid, and this 2 lines up with this section of the grid, and so our 4 is going to go here. And you can either put nothing in this top triangle, or you can put a 0, because it's just 4. Then we have a choice. We can work our way this way, or we can work our way that way. I'm just going to work my way down. So 2 multiplied by 3 is 6. Again, put a 0 up here. 1 multiplied by 2 is 2. And 1 multiplied by 3 is 3. So now I've got all of my numbers set up. Right? I have broken down 12 and 23, and I've filled in my grid. Now what I'm going to do is I'm going to add my numbers together, similar to what I did in the traditional multiplication method. I'm going to add diagonally. So any numbers that are inside of these red lines, I'm going to add together. In this case, we don't have too many. 6 is on its own, so it's 6. 3 and 4 is on its own, or are together, so they get added to 7. 2 is on its own, and 0, of course, is nothing. And so we end up, if we read it left to right, with our product of 276. We'll get the same answer using a different method. Some people prefer this method because they're able to break down the numbers and see them and add them all up. The primary difference between doing this and doing the traditional method is in the traditional method, there's a bit more combining factors. Instead of here where we multiply 2 multiplied by 2, 2 multiplied by 3, 1 multiplied by 2, and 1 multiplied by 3, over in that traditional method, we essentially multiplied 3 by 12 and then 20 by 12. And so we had a bit less to add up at the end, but a bit more to think about while we were writing things down. Let's head on over to the second question and see what happens when these aren't all zeros. So first thing we need to do is set up our lattice again. Making sure to start on those right-hand side corners and work our way down and to the left. Starting in the top right again, we have 32 multiplied by 16, so 2 multiplied by 1 is 2. 2 multiplied by 6 is 12. And so this time we're going to put our 2 in the bottom triangle, and we're going to put our 1 in the top triangle of this grid square. Next, we have 3 multiplied by 1. That's just 3. And we have 3 multiplied by 6, which is 18. So we have a few more numbers this time around. Again, we're going to add them up diagonally. 2 is on its own. 8 and 2 is 10. Add 1 makes 11. We cannot fit 11 here, just like in every other type of operation. When we have more than 9, we need to regroup. So we're going to leave 1 here, and we're going to place another 1 just somewhere inside of our grid. Not out here, because this is where our product is going, but somewhere inside of our grid. You can put in that empty space if you want, but they're not always empty, so I just put it here. 3, add 1 is 5. And we end up with our product of 512. So those are our two methods that we're going over today. We've gone over traditional multiplication and lattice multiplication. Both of these methods, in principle, do the same thing. They take larger factors, and instead of counting 12 groups of 23 or 32 groups of 16, they break down those factors into their principal parts into single digits, multiply those single digits, and then add up all of those small products to make our end product. I'm Mr. Ford, and this has been 2 methods for 2-digit by 2-digit multiplication.